this video, you'll see what happened when I took an RC SR-71 Blackbird and upgraded it to see how fast I could get it to fly. I installed new motors, improved its aerodynamics, and fitted a powerful solid rocket booster that could be activated mid-air. I've been challenging myself to build faster and faster rocket planes here on ProjectAir for a couple of years now, slowly increasing their speeds with each new project, solving problems along the way and trying my best to get them back without being completely obliterated in the process. This plane would be quite different, as it would be the first to use a new type of rocket engine with a super long burn time. So the plan was to take a very standard RC jet and modify it to fly as fast as possible in a straight line on battery power alone. Stage 2 would be to then increase this top speed by activating a rocket engine mid-air, which would cause the plane to accelerate to an even faster top speed. It seems appropriate that we use the SR-71 for one of these speed aeroplane projects. The Blackbird was one of the fastest planes ever made. The problem is though that this foam RC model isn't really designed for high speeds, so maybe we could change it and make it more like the real thing. Firstly, we needed to find out exactly how slow the plane was to begin with, which meant getting it out of the box and getting it assembled for its very first test flight. The plane came with two very small 40mm electric ducted fans, which propel the plane through the air using power from the onboard LiPo battery. To pitch and roll the aircraft, the plane was fitted with 4 microlinear servos, but these looked a little bit on the flimsy side. Would they hold up when we started to increase our air speeds? For now, it was time to head up to our normal flying field and put this thing in the air as its makers intended.
For some reason I'm getting a warning on my transmitter, but it's in the sky, coming around. Well, it's working. Doesn't seem particularly fast at the moment. Woo! Look at that. That looks so cool. Let's go full throttle now and do a low pass. Woo! That was pretty fast, wasn't it? So we've only got a couple of minutes battery, so I'm going to just try and make the most of it. Oh, okay, I think it's telling me that it wants to land, so let's bring it in. Right, let's see how fast the plane went. 108 kilometers an hour. That's 60 miles an hour, I think. So yeah, let's see if we can improve this aeroplane back at the workshop.
Okay, so there are some very easy things we can do to this aeroplane to make it faster, and it's important to make it as fast as possible before we add rocket engines to it to make sure that we're really optimizing the top speed of this aeroplane. Now, one of the easiest modifications I can do to this aeroplane is to remove these cones on the front of the engine nacelles. We just want to get as much air into the ducted fans as possible, and at the moment these are restricting that. The next key thing that I needed to address was the streamlining of the aeroplane. I absolutely needed to record the flights from on board to analyze what the plane was doing mid-air. But the camera I was using was massively increasing the frontal area and overall drag of the otherwise quite slippery SR-71. I decided to change to using a much smaller Insta360 Go 3 camera instead of the big bulky run cam. With the new camera in place, we now had a much more optimized setup for capturing onboard video. While making these initial modifications, I also tested out some new batteries from Spectrum to see if we could get more power out of these ducted fans. It turned out that these fresh new batteries made a big difference, which you could also audibly hear. Now I was excited to see how these upgrades would affect the Blackbird's top speed.
Ready, so that's rolling. This is definitely recording. Yep. Stop, read, 150! That's way faster, look at that, 150.
We'd increased our top speed by a decent 27%, but now I wanted to push the plane over 100 miles an hour on battery power alone, which would be much more difficult due to the problem of increased drag at higher speeds. Air resistance actually works in a bit of a strange way. Drag increases as an object moves faster through the air, as it collides with more and more air molecules, exerting an opposing force. As our SR-71 increases its speed, it will hit more of these molecules with more force, meaning theoretically if we want to fly twice as fast, we would need to 4 times the power, which is quite a tall order. We'd already maxed out on battery power, so now the best way to squeeze more thrust out of the electric systems would be to upgrade the Blackbird's fans. Through this rudimentary smoke test, I could visibly see the volume of air being sucked in by the electric ducted fans. I could also see the speed of the air exiting the exhausts, and it was really interesting to see that there wasn't actually that much air being moved here. The original fans were quite small, so increasing the fan size would allow us to pull in more air and chuck it out the back faster. I found some new larger fans that were repurposed from one of my ground effect fan car projects, and after being quickly serviced, were pretty much as good as new. Now I could remove the old motors from the SR-71, which required a bit of aircraft surgery, and then I could hook up the new fans directly to the internal flight computer to see if they would work. It wasn't all straightforward though. I found I had to remove quite a lot of foam from the intake, and I also had to add nose weight to correct the balance of the plane, which would add to our all-up flying weight. This would become a bit of an issue later on. So, would the fans move more air? Well, there was a very obvious difference. Far more air was being sucked into the primary intake as well as into the secondary vents, and it seemed to be shooting out of the exhausts much faster. This was a big step towards our stage 1 goal of getting this plane over 100 miles an hour on electric power alone. The problem was I'd now made the plane much heavier, so would it still fly?
Oh, she's got some power. Oh dear. I think we're okay.
After adjusting the trim of the elevators, I could rely on the flight computer to keep the plane level and try again. With that hair-raising takeoff out of the way, I finally got the plane airborne and accelerating hard. Lining up, I could do a couple of speed runs before I'd have to land.
Yes! Haha! 163.
Finally, we'd achieved 101 miles an hour, meaning stage 1 of the project was complete. Now we could turn attention to stage 2 and start experimenting with some rocket boosters. A solid rocket engine operates based on a principle of combustion of solid propellant. The casing of the rocket motor contains a solid propellant mixture, composed of fuel and oxidizer. When ignited, the solid propellant undergoes rapid combustion, producing hot gases which shoot out of the nozzle, generating a thrusting force in the opposite direction. Now, what's going to be different about this rocket plane to other rocket planes I've made in the past is to do with these rocket motors. These F-size rocket engines burn for a lot longer than those I've used before. These release their energy much more slowly, allowing the vehicle to accelerate more gently. This rocket plane here used a much more violent engine, and it barely survived.
3, 2, 1, fire!
If I was to use a much more gradual engine to sort of accelerate slowly, then maybe this will be more easy to fly with and also more survivable for the aeroplane. I wanted to test the rocket engines and gather data before strapping them onto the precious SR-71 Blackbird. For this, I would use a data logger, seen in previous videos on my channel, that can be used to measure thrust, such as the thrust from these giant rubber band motors, used in my rubber band plane video. This load cell and data logger would need to be mounted to something, and initially we thought about 3D printing a base from plastic, but that might not have been the best idea as we were going to be dealing with rocket motors that get a bit hot. So we realised that we needed to fabricate our test stand from metal, but instead of doing this ourselves, we got this part machined by PCBWay, who are actually sponsoring this video. After waiting for the parts to arrive, we could unpack them and quickly assemble the finished test stand, complete with electronics for measuring the thrust of the rocket engines.
Right, I'll press this one, it'll go do, 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 and then start.
Alright, so we're here with the load cell. Now we're going to do our first rocket engine tests. We've got Emma here who's designed the load cell. So yeah, we're going to fire it off now.
We test fired 3 identical motors, and the data showed that we get about 100 newtons of average thrust across a 7 to 8 second burn. So yeah, pretty good. Thank you very much to PCBWay for sending through all of the parts for this rocket engine test stand. It's been really, really helpful. All you have to do is design some parts in CAD and then upload them to the website, and you can send them off to be made for you. It's really straightforward, and there's loads of great tools on there to manufacture things in different ways. So make sure to check out PCBWay with the link in the description. Thanks very much to them for sponsoring this video. Okay, now I've tested the rocket engines on the ground, I can start work on mounting them to the RC plane. As our speeds were increasing, I'd actually found it quite difficult to keep track of the stealthy black aeroplane in the sky when I was controlling it. So my solution was that we would paint this aeroplane a special colour. As you might have noticed, previous rocket planes on my channel have been orange, mostly. However, I wanted to try something a bit different with this particular aeroplane and paint it gold, because I thought it might be a good opportunity to see whether the shininess of gold and the reflective nature of it might make it even easier to see the aeroplane's orientation. Now with the gold paint, the unique looking Blackbird could be reassembled complete with ProjectAir markings, and of course my Patreon's names as a thanks for signing up to my Patreon. You can sign up with a link in the description to add your name to my future builds. Now to make a mount for the engine using some cardboard tube. Now, to make this rocket plane work electronically, I found I'd have to make some big changes. Remember that flight computer from earlier? Well, it turned out it wasn't actually very customizable. This meant I'd have to switch to a brand new radio system. This wasn't actually a bad thing, as it gave me an opportunity to upgrade the radio system to one with much more redundancy and better range. The trouble was, with this bulky receiver, there was simply no room left in this aeroplane to fit a gyro, like had been built into the flight computer. This was now going to be a totally analog experience, which would require me to pilot the plane with all the flying skills I had. With the new control systems finally all wired up, new stronger servos installed, and the powerful fans working at 100% again, we could give the igniter circuit a test. Woo! With that, the plane was all finished and ready for what this video has all been leading up to, the first rocket-powered test flight, to see just what these long burn motors would do. Power on, seal hatch, check control direction, igniter, circuit LED plug-in, test igniter circuit, camera start recording check. Alright, so we've got the aeroplane here, we're now at the flying field, and we've got the rocket engines that we're going to be using on this test. We've got the 8-second burn. This engine will burn for 8 seconds and give us, a good solid boost of about 1 kilogram over, constant thrust. There's a very low odds of success with this whole thing. It could all go very wrong very, very quickly. Flight pattern is take off into the wind, do a circuit, and then hopefully if all's looking good, if we haven't crashed by that point, we'll get the green light and go for an ignition of the rocket. Let's see what happens. Okay, going to come around. Okay, we've got the green light. Okay, and then 3, 2, 1, throttle up and fire! Right, trying to get orientation, the gold paint's working.
Okay, we're down. I think we're down in the field.
Lost.
Oh dear, that was so uncontrolled. It was so difficult to keep it straight without the gyro. Right, I'm gonna go and try and find it with the scout drone. I think we're only a couple of fields across. Thankfully it's gold, so it'll be quite easy to see. That's it, found it. We found it. So we got a successful burn. The airplane didn't crash on takeoff. There's lots of positives. Not sure how fast we went though, so that's what we're going to go and discover now. Let's see how fast it went with the GPS. Do you see it? Where's it gone? It was here. Oh, there it is. Well, it's sort of in one piece. It's a bit dug into the ground. Look at this. It's proper stuck in. Oh my God, it's actually wedged in. God, I can't actually pull it out. I cannot actually pull this out of the ground. Oh, there we go. So, the big question, how fast did it go? Okay, so, stop, read, 200 kilometers an hour. 200 kilometers an hour exactly. Look at that.
That is spot on.
That is pretty impressive. Right, let's see how badly damaged the aeroplane is back at the workshop, and then we can see if it'll ever fly again.
So we tried to fly the aeroplane again, but unfortunately ran into more problems with hand launching, and unfortunately we weren't able to get the aeroplane back up in the sky. The aeroplane was just too unstable and just ridiculously hard to keep level. I had to take a really big run up to get the right airspeed, and yeah, it was almost impossible. I kept damaging the aeroplane and we had to keep going back to the workshop and going back out again to the field. And yeah, unfortunately on one of these tests, or one of these attempts, the aeroplane ploughed into the ground and was instantly written off. So this aeroplane is pretty much destined for the ProjectAir museum now, but it's, yes, we've definitely learned a lot from it. So long burn rocket engines, will I be using these on the next aircraft? Well, actually, if you look at the test flight footage, it seems that the aeroplane sort of ran out of space when it was still accelerating. So I had to pull up and sort of bleed off speed in a turn, and that meant that the aeroplane basically killed off some of its potential with how fast it might have gone if this was using all of its fuel up in a fraction of the time. So I think I'll be going back to using sort of shorter burn, more violent rocket engines in the future. We got it in the air that one time and managed a pretty impressive top speed of 124 miles an hour. We actually doubled the top speed of the stock aeroplane, or pretty much did. It was, I think, 10 miles an hour off. So we've learned a lot from this part of my rocket plane program, and in the next video I'm probably going to be starting work on a brand new type of rocket propelled aircraft, although it's going to be very different. So if you want to check that one out, make sure to subscribe so you get notified, and also check out another video in the meantime while you're waiting for the next video on ProjectAir to come out. I think you'll like this one too, so click on that one next. Thanks very much for watching this video, and I'll see you on the next one.